Abdullah, and welcome to my electrical site engineer course. The topic for today we have central battery system. So in this topic we will cover about CBS, what is a CBS, what are its components, and types of emergency lights, how many types of emergency lights we have. We will also discuss about advantages of CBS and disadvantages. And then we will go for the site installation guide, and I will also discuss with you all the drawings that are necessary for the installation of central battery system. So let's discuss the central battery system. What is a central battery system? Basically, it is a centralized emergency lighting power supply system. So it is used in buildings to ensure that a light remains operational during a power failure. For escape routes, for exit signs, and emergency lightings. Okay, so it is basically a centralized system. We have one centralized battery packs and inverters, everything, and it is excuse me, it is powering all the lighting fixtures, all the emergency lighting fixtures in that building. So this is called a central battery system, and it works during the main power failure. When the main power fails, in that case the central battery system starts working. If you are familiar with a UPS system, so it is basically the same idea, but it is only used for the lighting fixtures. It is an arrangement where one large battery bank is installed at a central location. It could be usually a control room or an electrical room, and it supplies emergency power to multiple emergency lights throughout the building via separate circuits. So we have two types of battery systems. First, we have dedicated battery system, in which, for example, if this is a room, in that room we have four lights. In these four lights, for example, we want these two to be emergency lights. So these will have small battery packs that will work for 1.5 hours or whatever is the requirement of the project. And these two will be powered from normal supply. I mean, for example, if there is our normal distribution board, so it will be powering all the four. All four will be powered, but in case this one fails, then these small battery packs will start working. This is called dedicated battery system. But if we have a central battery system, so in central battery system we will have one panel. It will be fed from the emergency power. Okay, from emergency it will be fed, and then EMDB, and then it will power all the emergency lighting fixtures. So if the in normal case, it will be fed from normal power. If this normal fails, then it will be powered from the batteries that are available here. Okay, and also we will have a generator here, and this generator will be powering this EMDB system. So if all of these system fails, in that case, this the batteries that are here, it will be powering all the emergency lighting fixtures. So emergency lighting fixture will include our exit lights, directional exit lights, and also our emergency lights. So this is all about the basic understanding of a central battery system. Okay, let's talk about the main components of a central battery system. So the first component is the central battery unit. It houses all the battery banks, the chargers, controllers, and output circuits. So whatever the outside the panel is, it is called the central battery unit, where all the battery packs, all the inverters and chargers, and all the circuitry is available inside here in this panel. So this is called central battery unit. Then we have the batteries, mostly from lead acid or nickel cadmium batteries. Then we have the battery chargers for charging these batteries. Then we have the changeover devices or inverters that converts AC to DC, and then from DC to AC, because the lighting fixtures they work on DC. Sorry, on AC. So the batteries that work on DC. So these inverter has to change from AC to DC for charging the batteries, and then from DC to AC for providing power from the batteries to the lighting fixtures. And we also have a monitoring system here that monitors the battery health, the charging status, if it is charging, it is not charging, how much is the health of the batteries, and we also have circuit faults, if there is any faulty circuit available in that one or no. And then all of this data is given to our central server, or to the location where a person that is monitoring all the things of the building, so it is shown there to his PC on his PC, and also it is available on the HDMI or the display of the central battery system. Then we have the emergency lighting fixtures or lighting fittings. We have maintained and non-maintained ones. I will discuss with you what is maintained and non-maintained in the coming slides. And then we have our distribution panel. For example, if this is our central battery system, after this central battery system, we cannot connect all the circuits from here directly. So we have what do we have? We have one panel here. Let me erase this one. So this is our panel, our central battery system CBS, and then we have emergency panel here. So incoming comes from here to the central battery system. It is converted into DC to charge the batteries, and then after the batteries it is given to the outgoing one feeder, and it comes to this panel. And this inside this panel we have different circuit breakers for different circuits, and from each circuit then we have outgoing for a circuit. Okay, and the circuit is controlled from this panel. So this is called a central battery system, and we have this distribution panel here. As you can see here, this is our central battery unit. We have all the inverters and we have the battery banks here, and this is all the circuitry. It is shown here in enlarged view. You can see this is our incoming. We have this circuit breaker on the incoming, and this is our outgoing. We are giving it to the distribution panel, and here it's all inside is its circuitry, and these are our auxiliary contacts or the points where data is given to the other systems. Let's discuss about the types of emergency lights modes in central battery system. First of all, we have the maintained one. The maintained one means that these will be remain on always. In even in normal case, in emergency case, these will be on. So, for example, we have the directional exit light. So the exit light shall be turned on all the time. It should be showing the direction or should be showing the exit where the exit is. It should be on all the time, okay, even in normal case or in emergency case. So this is called a maintained one. We have the non-maintained one. The non-maintained one means if the power fails, in that case, these non-maintained one will turn on. For example, in a room where we have four lights, two emergency, two normal. If the main power fails, these two normal will fail and these two emergency will turn on or they will be kept on. Then we have the sustained one. The sustained one means, for example, if this is our lighting fixtures, inside we have two lamps. Okay, these are our two lamps. So one will be fit from emergency and one will be fit from a normal power. So if this is from emergency and this is from normal power, this one will fail in case of when the main power failed. So the normal one it will fail, but the emergency one it will still be turned on because it is powered from a central battery system. So this is called a sustained one. Okay, so we have three types: maintained, non-maintained, and sustained one. Now let's talk about the advantages of a central battery system. First of all, it is easy to maintain. Why is it easy to maintain? Because all of the system or the central bank that is placed in one central system, okay, or in one central location. So whatever you do with the battery, if you want to maintain, if you want to change it, or you want to do some other maintenance, for that one you will have to go to only one location. You do not have to circle around all the buildings. You have to come to that one location, and from that one location you can do all of its maintenance. The next advantage is that it is a central monitoring system. You can monitor all of the system, all of the building from one central location, and that is the central battery bank or the central battery unit. From there, you have to go and check in the screen whatever is available for you, all the battery health, the charging status, the circuit faults, all of them will be showing for you in one central location. The next advantage is that you will have a better battery life. For example, if we have large batteries, in case of large batteries, they give us longer life. They last longer from 8 to 10 years. So after 8 to 10 years or even 15 years, you will have to change them. But for the small battery packs that are attached with the lighting fixtures, you will have to change it in 1 year or 2 years. After 1 or 2 years, you will have to change them, or maximum after 5 years, you will have to change them. Then you will have to go. For example, this is our building. and we have different rooms inside here. Okay, so you will have to go to each room and you will have to change all the battery packs, or you will have to change the even the lighting fixtures, because you cannot change just the battery pack. You go and you have to change the lighting fixture all. So it is better to change the from the central battery location just the batteries, instead of going through all the building and changing each and every lighting fixtures, emergency lighting fixtures. Okay, also they are easier to test. Only you need to go to a central battery location. For example, this is our electrical room, so you will come here and you can check all the outgoing circuits from one central battery location. And compliance or by usage, these are required in hospitals, in airports, in malls, and in metro station. Basically they are required where we have to deal with too much public. Okay, so where the emergency lighting must be 100% reliable. So in that case, you go for the central battery system. So these were some of the advantages of the central battery system. Now let's discuss about the disadvantages. So first of all, it has a high initial cost. So you will have to bring the batteries, all the battery, central battery unit, and each and everything that are related with the central battery system. So its initial cost is very high. It is more expensive than a self-contained system. Next, you will have a problem of the voltage drop. For example, if you are installing the dedicated or self-contained system, so you don't with the same lighting fixtures you will have the battery pack available. Okay, but in central battery system, for example, this is your central battery system and your lighting fixture is there, so you will have to bring one cable here and your batteries are here, and it will be providing power from here till this lighting fixture. So a voltage drop in this case will occur. So whenever the you are doing the calculations, or the designer is doing calculation, he has to keep in his mind that there will be voltage drop, and he must do it carefully, all the calculations, and then size this cable accordingly, and also size this batteries accordingly. Okay, so it also increases the cost of the central battery system. Then we have dependence on a single system. If this system fails, if the central battery system fails, then all of the emergency system in your building, it will fail. It will not work. Okay, so there is also a problem. For example, if in a dedicated system, if one lighting fixture fails or one pack fails, the other lighting fixtures will still be working. But if in a central battery system, the central battery unit fails, so in that case, all the building lighting fixtures, the emergency lighting fixtures, there will fail. So it is a reliable, but also it is not reliable. If the central battery system fails, there is no redundancy. Entire emergency lighting can go down. That is why if we have, for example, central battery system here, so it is provided power from EMDB. Okay, EMDB, and this EMDB is fed from generator. Okay, and also from the MDB, that is the main power, or MDB is powered from transformer here. So in case if this central battery system fails and this normal is also failed, so we provide power from the generator, so we will have a redundancy. That's why the cost of central battery system, it increases in that case. But as you know, according to the excuse me, according to the electrical companies, we have to provide one generator, mostly in the Gulf countries. According to SIC or DIVA, you have to provide a generator. That's why putting a central battery system with this redundancy is helpful.